Okay, so today we will be doing 1.1 to 1.6 AP review for PRECALC. Okay, so our question today is number 21. For the function y equals g of x, identify the characteristics. So today we will be identifying the characteristics of this graph. Okay, so let's get started. First, we have to find the domain. Okay, we know the domain is how far left and how far right the graph can go. Here, we can see our graph is pointing up and it's going left all the way up, which means it's going all the way to negative infinity. It's going all the way left. And here to the right, we can see the graph is going all the way up in the positive right direction, so it's going to infinity. So our domain is negative infinity to infinity. And infinities always get parentheses. Now we are looking for range. A range tells us how low and how high our graph goes. We can see that our graph goes up forever, so we know it'll go in the positive infinity. But our graph cannot go any lower than this point right here, -3, -8. And for the range, it is always the y's. So the lowest it'll go is -8. And it has to be that closed bracket because it can no longer go any lower. And then the highest it can go is infinity. So that's that question. Now we're looking at C. Some of you might get confused because you're like, why is this here? Well, all I was really saying is y is less than 0. The function g of x is less 0. So during what segment is the function below the 0? And the 0 is right here. So we can see -6. It begins to go down into the negatives until it reaches 0.25. And then it becomes to get positive again. So our graph is negative from -6 to 0.25. Okay? And now we need to find the zeros and their multiplicity. If you don't know what multiplicity is, we'll get into it after we find the zeros. So the zeros for this graph are as follows. This is also how you notate the zeros. If it asks for x's, we would say x equals, but it's asking for zeros. So the graph is at y equals 0 at -6, 0.25, and 4, 0. So our zeros are -6, 0.25, and 4. Okay? And now, as for their multiplicity, at x equals -6, hold on. Technical difficulties. Okay, so at x equals -6, our graph is going straight down. So it's only crossing that area without anything stopping it. So its multiplicity is only one. So its multiplicity is 1. Why? Because it's only crossing once. It's not bouncing. Okay? So now we move on to x equals 0.25. Its multiplicity is also 1 because it's crossing. It's not stopping, it's crossing. So it's also 1. At x equals 4, that's where we begin to see that bounce I was talking about. Since our graph is going down, up, it's stopping at that point, but it's going down once. And then when it starts back up, it's at that point again, which means it has a multiplicity of 2. That's as much as I can really explain it. But just think about it this way. Like, if it's like a car going, if a car passes through like Walmart once, boom, it's passing through Walmart. So then you're going down Lake Street. Hold on, my pencil turned off. Okay. Oh my God, it's running out of charge. Anyways, so it's like you're going down Lake Street. So you're going down Lake Street, and first you pass McDonald's, boom, once. You keep going straight, you pass JetBrite, boom, once. But then you come to Popeyes, and you stop. You stop at Popeyes, and then you start back up at Popeyes. So you ended there, but you also began there. So that's twice. Okay? I'm probably wrong, but like that's how I explain it. So now intervals where g of x, hold on guys, I need to like start using my finger because my pencil died. Okay, so intervals where g of x increases. So g of x is increasing again at from negative 3, negative 8 to 2, 2. And then again from from 4, positive 4 to infinity. Do you guys see? It's going down here, but then it begins to increase up here all the way to negative 2, then decreases, and then increases from 4 to positive infinity. So our numbers are as follows. Negative 3 to union, because we need to unite those 2 points where it increases. And don't forget, increases has a C, which means parentheses. Okay? Delete that, and then 4 to infinity. Oh, that's so chopped. Anyways. Okay. Intervals where g of x decreases. So again, we're going from, this is negative infinity. Yeah. Negative infinity, anything that has nothing to do with range will be x's. So our x, according to our domain, is negative infinity from the farther left. So negative infinity, it's going down to negative 3. Negative 3. And then, these are parentheses. Yes. Okay. And then union, decreasing from 2 to 4. Okay. Now we move on to relative maxima. Relative means local. So your local maxima would be something like 2, 2, because we know our graph still keeps going up. So there's a bigger maximum than just 2, 2. So for this notation, we do the y first, which our y here is 2, at x equals 2. Now on a graph, you have your x, which is 2, 2. And that is how it is. Okay, relative minimum. Now this is your local minimum. Since this graph is an even graph going in the positive direction, we have a local minimum and an absolute minimum. Which one do you think would be our absolute minimum? The lowest one. Yeah. And then our relative minimum would be the second to lowest one. So our relative minimum in this case is 4, 0 right here. So then we'd graph it as 0 at x equals 4. Now we're looking at our absolute maximum. Our absolute maximum, like I said, is the absolute highest point. However, due to the graph that we're given, we cannot pinpoint that value. So in this case, it does not exist. This is just based off of the graph. If you were given the whole graph, then it would exist. But at this point, it does not. Absolute minimum is the lowest the graph can go. Since it's an even graph in the positive direction, it's going up forever, in both going to the left and going to the right. So there is a minimum, and the absolute minimum in this case would be negative 3, negative 8. So negative 8, our y first, at x equals negative 3. Okay, and then we come to our point of inflection. Our points of inflection are the halfway point between concave down and concave up, or concave up to concave down. And this is basically just where it stops being a certain concave, like on concave up, and then it starts to be concave down. Okay, so here we know our graph. Oh my god, let me erase this. It's so ugly. Okay, so here we know our graph is going concave up, and then a point of inflection would be right here, and then it begins concave down, and another point of inflection would be right here because it starts going up again. So there's 2 points of inflection in this case, and we find the points of inflection by finding basically, like, how do you say it? Yeah, no, I'm gonna just tell you. So our points here are -3, -8. For the left, we're reading this left to right. So -3, -8, and then we have 2, 2. Okay, so now we have, this is our x and our y's. Now we must add both and then divide by 2 to get the halfway point. Okay, so -3 plus 2, add the x's with the x's, add the y's with the y's, divided by 2 equals -1/2, which is also known as -0.5. And then we have 2 plus -8 equals, divided by 2. This is our y. This is our x. Okay. And this is equal to -6 divided by 2. -6 divided by 2, -3. So then our first point of inflection is -0.5 at -3. This is so chopped right now. Like, I can't. Okay. And then if we, oh, look, we're showing the answers. Anyways, so as we can see right here, we got it right because we added both and then we divided by 2 and we got our answers. Again, this can be -0.5. And then we got -3, and then you do the same for the other side, which you take 2, 2, and 4, 0, and then add those together. Here we have our y's, or nope, never mind, I lied. So our x's, and these are our y's. And then we find this point. And you know that's true because if you go right here, you know you're at 3, and then you're at 1. Right above 0, right above 0, right below 2. And again, -0.5, you're right here. -4 is right here, and your point of inflection falls right here. So that's how you know you're right. Now, intervals where g of x is concave up and where g of x is concave down. Okay. Okay. Oh, let's go back. Okay, so here we're gonna show where g of x is concave down. So concave up, my bad. Concave up, think about it as a smiley face. Concave up, like this. So we see the smiley face going up right here. Don't forget your point of inflection, so that's when it turns into something else. And your point of inflection right here. And then again, it goes concave up. Let me highlight this. Yep, okay, this. Down, point of inflection, another point of inflection, and then it's smiley face up here. Like smiley face and then smiley face. Okay? But then we know it's concave down from the point of inflection to the other point of inflection because it's a sad face. So we'll come back to that one. But as for our concave up, we know it's from -infinity, parenthesis, to -1/2. I'm gonna put a parenthesis. It's probably gonna be something else. It's fine. And then it begins again at 3 to +infinity. And now where it's concave down, we know it's gonna be from -1/2 to 3. Think about it this way. You have a gap right here. If you're asked for the other interval, then you know it's going to have to fill up that gap. So now you know your graph is full and it has no holes because you were able to fill up the gap. Okay? And now as for the end behavior, we know our limit notation is limit. But don't forget, this is not f of x. This is a g of x graph. So it's g of x is equal to, as x approaches negative infinity, what did we say in the beginning? As x approaches negative infinity, it's going up in the positive direction. So as it goes to the left, it's going up in the positive direction. So positive infinity. And then as for limits, g of x again, for the right side, we are going up again, so positive infinity. And don't forget, as x approaches positive infinity. And that's it for this review. Thank you.